Ever wondered how a metal spoon left in a hot bowl of soup eventually becomes too hot to touch? It's all about heat transfer by conduction. This fascinating phenomenon happens when particles, be they molecules, atoms, or free electrons, interact within a material. It's a process that can occur in solids, liquids, and gases. But here's the kicker. It's more efficient in solids. Why, you ask? Well, it's all due to the closeness of the particles in solids. So what happens when a material is heated? Let's delve deeper. When a material is heated, its particles get all stirred up. Picture this: a bustling dance floor where the dancers are the atoms, molecules, or free electrons of a material. As the music, the heat, picks up, these dancers begin to move with greater intensity. This is because they've acquired more kinetic energy, the energy of motion. Think of kinetic energy as the rhythm that drives the dance. With more heat or music, the dancers are more agitated, their movements more vigorous. They vibrate, spin, and jostle about more intensely. The more heat supplied, the more kinetic energy they gain, and the wilder the dance becomes. This is the commencement of heat transfer by conduction, a process that can occur in solids, liquids, and gases. However, it's most efficient in solids because their particles are closer together, much like dancers in a crowded ballroom. But how does this energy get transferred from one particle to another? The answer lies in their interactions. The transfer of energy from one particle to another is at the core of heat conduction. Picture this. When particles gain excess kinetic energy, they become somewhat like energetic dancers, moving and vibrating more intensely than their cooler counterparts. This energy, this dance, doesn't stay confined to one particle. Through collisions and interactions, this kinetic energy is passed on from one particle to another. It's rather like a relay race where the baton of energy is handed over from one to the next. This transfer isn't random, though. Heat, or kinetic energy, flows with purpose from regions of higher temperature to those of lower temperature. It's a journey from the hot to the cold, a quest for balance. The efficiency of this transfer depends on the material itself. Some, like metals, allow this kinetic dance to flow smoothly, efficiently transferring heat. Others, like plastics or wood, resist this flow, making them excellent insulators. The dance of heat transfer, it seems, varies with the dance floor. Ever noticed how some objects heat up quicker than others? That's because of their conductive properties. Metals, for instance, are good thermal conductors. Their free electrons easily transfer kinetic energy, heating up quickly. Contrastingly, plastics, wood, and porous materials are thermal insulators. The particles in these materials are spaced further apart, making energy transfer much harder, thus they heat up slower. The rate of heat conduction depends on several factors. Understanding this fascinating process gives us control over how we heat and cool our world.